Hi there parents, welcome back to another math hour. Today I'm just going to show you how to find the specific sequence number uh, in a geometric sequence when you're given a term. And we know how to do the basic geometric sequence formula. We're going to use that along with the term number information to find out what number is at what position in a sequence. It'll be easy when I show you an example. So let me start off with a simple example which I took in the past. Let's try these numbers here. Let's try um, 3, oh, let me get this a little bit bigger. How about 3, 9, 27, 81, and so on and so on and so on. Okay? Now, the question is this. I want to know at what, I want to know what is the number of the sequence, of this particular sequence. What is the number in the sequence at term number 25? Okay, so again, just to recap, every single number here is in a position or something called a term number. This 3 right here is term number 1. Term number 2 is 9. Term number 3 is 27. Term number 4 is 81. I want to know that at term 25 or position 25, what is the value of this number? What is the number in this particular sequence? Geometric sequence. And in order to do this, I need my geometric formula. Let me write that down right now. So I know the geometric formula is a sub n is equal to a sub 1 multiplied by the common ratio all to the power of n minus 1. Okay? Now, we have a lot of numbers here, so let us first designate the numbers. A sub 1, my starting number in the sequence, is 3, because that's what the sequence is starting with. My common ratio, in other words, what number did I multiply by 3 to get 9? And we found out that we were multiplying everything by 3, times 3, times 3, and so on. And that is my common ratio. And finally, my term number, n. What term number do they want me to find out? And they told me to find out the number at term number 25. So the n is equal to 25. Knowing this, I simply plug in these values in my formula. So the n is 25, so I'll say a25 is equal to a sub 1, which is 3. My common ratio is also 3, and this n exponent is 25 minus 1. You see that, kids? You have to substitute the values in the right spot. And now we can do the math. Since there's an exponent, let us do this first. Let us do 25 minus 1, which is easy enough. And that is a sub 25, which is equal to 3 multiplied by 3 to the power of 24. 25 minus 1 is 24, okay? And again, PEMDAS, we have to do exponents first. So we have to do 3 to the power of 24. This is where your calculators come in handy. I'm going to have to use a calculator for this as well. So 3 to the power of 24 is equal to a huge, huge number. And do not be surprised, okay? This is quite common in geometric sequences. You will get a gigantic number. And 3 to the power of 24, and I'll have to write this down, is 282 billion 429 million 536,481. Okay? If you plug this in your calculator, this is the number you're going to get. And yes, you will get gigantic numbers like this. And we're not even done yet. Once you have this number, you still need to multiply it by 3, which I'll do right now on my calculator. And now, kids, this will be our final answer. The number at term 25 in this particular sequence right here is going to be 847 billion 288 million 609,000 443. And that is the answer to this question. And this is the number that belongs at position number 25 or term number 25. You see that, kids? That's how you do it, okay? You will get gigantic numbers like this. It's quite common in a geometric sequence. Let me show you another quick example. Let me see if I can make a little bit more smaller number, something more reasonable. Let me give you the sequence which I gave you last time. How about fractions? We have 1 over 5, 1 over 10, 1 over 20, 1 over 40, and so on. Okay? And I would like to find out what number is at term number, oh, I don't know, term number 12. Okay? Again, this is term 1, this is term 2, this is term 3, this is term 4, so on. I want to know at term number 12, what number is this? Let's use a geometric sequence again to help us out. Let's use blue here. So a sub n is equal to a sub 1 multiplied by the common ratio to the power of n minus 1. Let's find out the values. A sub 1, the starting number, is 1 over 5. My common ratio means, what did I multiply? Well, if I remember correctly, I multiplied everything by half. Okay, so my common ratio is a half. And of course, my n value, the term number value, as they gave over here, is 12. And now I'm just going to plug it in. Let's plug these numbers in. So a sub n will be a sub 12. My a sub 1 is 1 over 5. My common ratio is 1 over 2. And my n is 12 minus 1. Okay? You see? Just plug it in and now solve. We'll start with the exponents first. So a sub 12 is equal to 1 over 5 multiplied by half to the power of 11. And I'm going to use my calculator. So half is what? It's 0.5 to the power of 11. And that is equal to, that's also equal to a weird number. Let's do it. A sub 12 is equal to 1 over 5 multiplied by 0.000482813. Now, I don't have a scientific calculator. I'm using a regular one. You guys do. And you can turn this decimal into a fraction, okay? Depending on your teacher. I don't have the capability, so I'll have to use decimals. So I'm not done yet. I've got the value. I did half to the power 11, and I got this answer. Now I still need to multiply it by 1 over 5, which is 0.2. So I'm going to multiply it by 1 over 5, and my final answer, a sub 12, is equal to 0.0000976,563. So what did I just find out? I found out that the 12th number in this sequence, or the term number, the 12th number in the sequence is equal to this very, very small number. Okay, 0.976,563. With your calculators, you could convert that into a fraction. Okay, but this is it. This is how you basically find the term numbers, whether it's arithmetic or geometric sequence. You just have to find the right values for each symbols here, the A1, the R, the N's. You got to substitute them properly, and you got to calculate properly as well. Okay? Remember your order of operations, and you should be good. All right? Thank you.